Okay, let's start. So we are gonna talk about, can you hear me? Yeah. JavaScript. Hopefully everyone is familiar with JavaScript here. So we're talking about, sorry, just this session is starting not really well. So yeah, we're talking about EcmaScript 6, which is the next version of JavaScript. And first of all, I'll give you an introduction of who I am. Sebastiano Armeli, I work for Spotify in New York. Also the author of MVC Applies to JavaScript. It's an ebook on the MVC pattern, if you are interested in the topic. But today we're going to talk about ES6. So it's really exciting time for the JavaScript community, because finally we are releasing a new version of the language, which is fantastic after 3-4 years, and lots of new features and lots of features that probably you already saw in other languages like Ruby and Python. So yeah, in this talk we're going to go through those features, but before doing that, I'd like to give you a bit of introduction, a bit of history of the language. So I don't know if you know, JavaScript was invented by Brendan Eich in 1995. At the time, he was working for Netscape. The initial name was Mocha, and after that it was renamed as LiveScript, and then after that it was renamed JavaScript in December. So Microsoft was using a similar version, which is called JavaScript. In 1996, they released this version. They didn't want to use the term Java, because Java was a Sun Microsystems product. And then in 1997, we got the release of the first edition, EcmaScript 262. That's the name of the official name of the specification. And this specification was made by the committee, the TC39 committee. The year after we got the second edition, and 1999 the third edition. In 2000 we got this, the edition 4 starting. So it seems like every year we got a new version, but in edition 4 had lots of new features, and there were lots of discussions about edition 4 breaking the web, because there were lots of different things that very different from edition 3. So in 2003 got abandoned, and in 2005, thanks to Brendan Eich, we've got the edition 4 starting up again. But still didn't have a consensus of all the parts. So in 2007, Microsoft and Yahoo started a slightly different version, which is 3.1, with small changes. So in 2008, we got this massive meeting in Oslo in June, where all the parts, Google, Apple, Yahoo, Microsoft got together, and they decided to release 3.1 first, and this version got called Edition 5 in 2011, and that's the version we're currently using. And then and they decided to put all the specifications belonging from Edition 4 into like a new version called ES6. And that's basically, ES6 is like the specs of set of specs that come after ES5. So now the status at the moment is that all the features are pretty much set. So there are only like a few tweaks, bug fixing. There are already implementation of EcmaScript 6 in Chrome and Firefox. And the release date should be June 2015. So we're really close to it. And the fact that a few browsers are implementing those features already make it possible to use ES6 already now. I mentioned a few terms here. So again, ECMA 262 is the name of the specification of the language. ECMA is the organization, TC, very nice, the committee of, so it's a set of people that basically decide the proposal and work on the proposals. Usually there is one or two champions working on a specific proposal. ES6, just as before. ES6 is a kind of, sometimes you hear this term, it's basically a pointer to the next version of the language. So today is ES6, but next year will be ES7. ES7 is the version after ES6. And we've got already like proposal for ES7, like object observe or async. So object observe is basically data binding, two-way data binding in JavaScript, which is really interesting. Anyway, for today, we're going to look at a few features of the language. So they're not all of them, but I guess some of the most interesting parts of ES6. So let's start with arrow functions. So fat arrow functions are basically a replacement of anonymous functions. So if you're familiar with the EcmaScript, this is nothing really new. So basically, this is the way we're going to write anonymous functions using the equal and the greater than sign. And in ES6, that gets mapped into like a function declaration. So we don't use the return and the function keyword. So that's kind of a nice syntax sugar, pretty much. But the main thing about fat arrow function, like in EcmaScript, is that the keyword this is bound lexically. And that means that the value of this is set to the outer function of this value of the outer function. And that's really important. We'll see an example later of how we can use it. And also, you don't have constructors using, if you use a fat arrow function, you don't have constructors. So that means that the prototype object on the function doesn't exist. Also, you can't apply, you can't use apply and call on fat arrow functions because it won't work, because you can't set this dynamically. And that's what you do when you do call, when you use call and apply functions. So other examples, you can still use the return keyword, and you can wrap the content, the body of your function in curly braces. And also, if you want to return an object literal, you use parentheses, because clearly you will, if you use curly braces, the compiler will be clear for the compiler where the curly braces, where they start and end. But as I said before, the most interesting part of fat arrow function is the fact that this is bound lexically. So what I mean from that is, let's say we've got an event handler for the click. I never guess what the point is. We got the event handler here, and the trick we usually do in ES3 is basically set this value to another variable, say that or self, and then through a closure we can access to that, right, inside the event handler. In ES5 we've got improvements in that, so we use bind. So we've got the bind method on the function prototype available, so we can do this, which is nicer because now we can use this inside the event handler. But still, it's not perfect because we've got the bind that we need to basically associate the function. In ES6, we can now use fat arrow functions, and that's really nice. So we don't need to do anything. This will be associated to the outer scope, and that's basically what we want. So this is basically the object. So if you're still wondering what the prototype, the hidden prototype of fat arrow function is, it's still function.prototype. So it's still a function, even if you can't instantiate a fat arrow function. Next question is, when would you use still the keyword functions? In three different scenarios. So first one is generators. So for example, so that's a new feature in the language, which probably you've already seen in Python. It's really powerful. We're going to look through generators later. Constructors. So as I said before, the prototype object doesn't exist. So you can't really instantiate fat functions, but so in case that you still need to instantiate constructors, when you need constructors, that's where you need functions. And methods and object methods. That's another use case, even though now we've got the shorthand notation, so you don't really need to specify a function for a method in an object literal. Now, second macro area, scoping, destructing, and parameters. So scoping, as you know in JavaScript, we've got kind of two different type of scoping, two different type of contexts. So the global, which is usually determined by the window, and then if you're working in the browser, and then the function itself. So the function defines the context. So differently from other languages like Ruby, for example, you don't have block scoping. So the block, when I say block, I mean like if statements or for loops, doesn't define a specific context. But now in JavaScript, you will be able to do that. So you'll be able to use keywords like let and const to define a specific context in the block scoping. So the variable will be available only in the context, in the block context. And the other thing is that, variable using let and const won't be hoisted. So hoisting in JavaScript, as you know, is basically means that the declaration of the functions goes up to the top of the context. So in case of the function, usually if you declare a variable inside your function, you will have the compiler declares the variable at the top as the first line of the function. So example, we've got this function, cp, and we've got the variable defined with the var, which is how we declare variables at the moment in JavaScript. And the context is defined by functions, right? So what happens is that the y variable gets hoisted, so the compiler basically writes a line here saying var y undefined, and so if you try to print out y, you get undefined, and the value of y is defined here, but the context is the function. With let and const, the context, the lexical context would be the block. So if you try to print out y outside the block, you get a reference error because the variable is not available. And that's really powerful, so it allows you to enclose variables inside the block scoping. That's a really nice feature. And const, same as let, but the thing about const is basically defining a constant. So allows you to, so if you use const, basically you can instantiate, initialize, and the variable as soon as you declare it, and also you can really redefine the value of the const. So it's a read-only value. So it's kind of a static final in Java. Destructing arrays. So destructing is about basically deassociating the elements of an array or an object into variables. So for example, if we've got like this array made by two strings A and B, if you use this kind of notation now, you're basically able to destruct this array into those two variables. So now x would be equal to A and y would be equal to B. Also, you can do like cool stuff like swapping elements from an array, and you'll be able to print it out. So it's really cool. Destructing objects. So you can do the same thing with objects. So given an object literal, you'll be able to destruct this object into two different properties, like you can see here. Also, another nice feature is that if the name of the property is the same as the name of the variable, you don't need to define this name twice. You can just define it once. So as you can see here, pretty much the value of w and width would be 50 in case of this object has got this property. Also parameters, default values. So this is the way that we commonly define the float values in JavaScript. So we don't have anything coming out of the box, like again other languages like Ruby. But now finally we've got the same feature as we got in Ruby. So you can define the float variables like this, which is really nice. REST parameters. So usually when you use JavaScript, you've got this keyword called arguments, which is used to represent the arguments of your function. And this object is not an array; it's an array-like object. So now, if you use the REST parameters, you basically be able to get an real array. So in this case, this function has got this this argument blocks, which is basically with the prefix dot dot dot, and the dot dot is the three dots is basically the rest parameter. So now this args will be an array. So you can use, like, for example, the for each method, which is available on arrays. It's available on ES5, by the way. I'm not sure how many use this for each, but it's available on ES5. So yeah, that's a really nice feature, and I guess we've been always wanting to have a similar thing in JavaScript. Also, you can do like stuff like having positional parameters and the rest parameters at the same time. So, for example, if I've got another argument as a first argument of this function, and then I use the rest parameter, I'm able to do stuff like this, where I invoke this function passing A, B, C, three arguments. So A will be associated to the positional argument, and then all the rest of the remaining parameters will go into this args variable, which is an array. And the dual operator of rest parameter is called spread. So you basically will be able to use spread operator to convert to the other operations. So basically converting an array into parameters, into a list of parameters. Now, third area is iteration generators. That's really important because generator is a big topic in ES6. And we'll see how it can really affect the way that you handle asynchronous communications. So first of all, let's start with iterations. So for of, that's a new construct that now we have available in ES6, in ES5. So as you know, for in is the current loop that usually people use, and it's got kind of limitations. Like one of the limitations that you can think is that if you try to do for in on an array, you're gonna get the index of the arrays. You're not gonna get the values of the arrays. That's quite frustrating. But now if you use for of, you'll be able to get the values of the array, which is pretty cool. So with for of, you can look through iterables and iterators. Iterables and iterators are kind of two different things, and we're gonna see what the difference is. For example, arrays, sets, and maps are iterables. Set and maps are like two new collections that we've got in ES5. So as I said before, if now you've got an array and you try to do a for of an array, you will be able to get the values of the array, not the indexes. So I mentioned before, iterables and iterators have different things. Iterables is basically just an object that has got a symbol iterator. So in ES5 and ES6, when you see this sign, means that we're talking about the symbol. So an object with the symbol iterator, which returns an iterator, that's an iterable, like array, sets, and maps. Whereas an iterator is an object that has got the next function. So generator is an iterator. We're going to do generator now. So as I said, you can produce iterators from iterables. So if you got an array, which is an iterable, if you apply those prototype methods, entries, and keys to an array, you will be able to get an iterator. And you can look through an iterator. You can also apply those methods to sets and maps, and you'll be able to get iterators on that. So given those iterators, for example, in this case, in keys, if I do an for all on this iterator, I will get the indexes of the array. Generators, that's a huge topic. So as I mentioned at the beginning, we still use the function keyword, but we use this star sign symbol. So the way it works is that the main concept about generators is that you're basically not executing a function from top to the end, from the beginning to the end, but you're able to stop and resume a function. So JavaScript works on a single thread, but so we're still working on a single thread, but we have like an ability of stop and resume the execution of your function. So first of all, you define a kind of constructor, generator constructor. Let's call it like this. And inside this constructor, you usually have like keywords like yield, yield and expression. Yield is used basically to stop and resume your to define the points where you can stop the execution of your generator. So you create the generator just basically executing this generator constructor, and once you've got the generator, you can apply the next methods. As I said before, a generator is an iterator, and an iterator has got the next method. So that's why generator is an iterator. If you apply a next on the generator, on this specific generator constructor, you'll be able to get this object here. So the way it works is that you basically call next, so you execute the function and you get to the first yield, and the output of this yield is determined by this expression, which is A, so the value is A, and also we've got another attribute called done, and it's set to false because we haven't finished to execute the full generator constructor. So if I call second time, I call next, what happens is that I resume the execution from here and I go to the next yield. The next yield returns B. So the value here is B and done is false because we haven't finished executing the function. Third time I call next, I resume the execution from here, and if you look at a function in JavaScript, if you don't have a return statement, it means that you do like the compiler does return undefined. So here it's like we've got the return undefined, so the value will be undefined, and that is true because we basically got to the end of the function. Also, another cool feature is that you can pass things inside the generator. So again, you got this generator constructor, you define the generator, you call next, so the value will be A. You call next the second time, get resume, return B. Third time, you resume the execution of the function, but this time in next, when you use next, you pass in a value. So what happens is that this value gets passed into the constructor. So this variable red_val becomes C. So we return C, and we got down equal true. So yeah, it's really cool. You can basically get things out from the generator, and you can pass in things as well. More advanced topic is that you can interact with promises, so you can really control the flow of asynchronously. So I'm not sure how many of you are familiar with promises in JavaScript. Okay. So promises is just like features in Java. It's a way of control asynchronously. Probably this example could be a bit advanced, but the main thing about this example is using generators. You can yield the promise, and if you yield the promise, you're able to basically wait for the promise to be fulfilled, so an asynchronous operation to be done, and then after that is done, you can, next time you call next, you can basically inject values inside the generator, and that could change the way you call the following function. But the main thing is that you can return promises, and so you can basically, depending on where you call the generator, if in the then or in error. But that's, I guess not many people know about promises, so I don't want to go into details too much. Collections, so that's another topic about ES6. So we've got different type of collections. So for example, Java, we've got sets, finally in JavaScript. So sets, same as Java, is basically a collection of values with no duplicates. You can put different types inside a set. So for example, you can create a set with numbers or with strings. You've got methods like add or as or delete if you want to add keys or ask if the keys is there or deletion for keys. And also you can create iterators from sets. Sets are iterable, so if you use values, you get an iterator. An example here, so you create a variable, countries, instantiated using new set. Then you can add items like a US and Italy, and then if you add another time the value US, pretty much it won't be added because it's a duplicate. Maps, that's another type of collection, same as Java, so it's just a key value pair. The cool thing is that keys can be objects, so they are not restricted to be only strings. And you've got methods like very similar to Java, get, has, set, so you don't have a put like in Java, you've got set. And other things like delete, clear, you can generate, again, iterators using entries, keys, values. You also have the for each method, which allows you to look through the map and get the keys, values, and the map itself, which is pretty nice. Example, you can define a map like this, so you just instantiate it using new map. You can set values using set. So if you print out this map, you get the map, you can get values out of the map, and you can delete it. It's really straightforward. Third type of collection is weak maps. That's more interesting collection. So weak maps allows you to avoid memory leaks in JavaScript. So the main difference between a map and a weak map is that the reference to the key object is held weakly. So first of all, the key must be an object, the key of the map, but the reference is not held strongly. So for example, if you create a map and you define the map with an object as a key, and then later on in the code you you say that the object is equal to undefined. So you basically that object should be ready for garbage collection, but it's not because it's still used in the original map, and that can create a memory leak. Instead, if you use weak maps, that reference is held weakly. So that means that that variable would be garbage collected. For the way that weak maps are internally done, we are not able to get iterators methods because you're not able to keep the state of internally of a map. Cool things you can do, for example, is defining properties of an object, private, even private, even if they are not really such a concept as private properties, using maps and weak maps. Third area, modularity, classes, and templates. So let's start with objects. So that's the way that you can define an object literal now in the ES6. So you can finally define the proto link for inheritance. And this is a definition of a method. So as I said before, you don't need the function keyword. You can now define a method like this. Module. So if you're familiar with, if you use any kind of module system now in JavaScript, I guess you're using either AMD or CommonJS. So AMD then uses required.js, usually for compiling, and CommonJS uses browser defined, usually. But they've got strengths. Required.js is more for a browser, where CommonJS is more for server-side JavaScript, because it's more synchronous, where AMD is asynchronous kind of loading. So in ES6, first of all, the web loading scripts will be depending on the environment, which is really cool. So it will be asynchronous on the browser and synchronous on the server. But also the way you define modules is a bit different, because you're able to use the keywords export to define basically public methods from a module. So in this case, out of this module here, this file here, I'm defining this public function using export, which is kind of mind of the CommonJS kind of syntax. And then you're able to import a specific function out of the module using import, which is really similar like what you do in Python. Also, now you've got classes. So that's really, I guess, Java-ish thing. You can use you've got classes and you can define constructors really easily. It's nicer. It's nice way of finally of object orientation in JavaScript. Even though it's just syntax trigger, at the end of the day we still have the prototypal inheritance. So you can also define subclasses using the extends keyword, and you can call super. So you can call the super class using super. Very, again, reminds a lot of Java. So for example, you can create classes like this, where you've got where you can call this superclass from a subclass. But at the end of the day, this code is the same as writing this code here in ES5. So nothing really changes. Also because ES6 needs to be backward compatible. Because one of the main goals is not to break the web, so everything needs to be backward compatible. So so the code that we saw before, it's the same as here. That's a classical way we do inheritance, right? So the define prototype of the subclass equal to the one of the generated from the subclass, which is define a constructor, and then this is the way we usually call a method on this superclass, which is kind of a bit nasty, right? So now we can just use super. And template strings. So at the moment in JavaScript we got lots of template engines, but now if you use the backtick, you'll be able to create those template strings and passing in variables inside those templates. And also, finally we've got multi-line support in JavaScript, which other languages, again, like Ruby has got, they've been having this feature for a while. Some API improvements, like we're gonna have like a few methods available in the string prototype, like starts with, ends with, contains, and repeat. They're all methods that we usually have from libraries like underscore, lodash, but now they're available in the language. Even on number, so you got is integer, is not a number, finite, which usually we got from the window, but now they're associated to the number class, which is cool. Array methods, so we've got a couple of static methods like from and of, and 3 prototype methods. Quickly, let's see the static method. So if you have an array-like object, like when you query like the O, you get a list of nodes from the DOM. If you use from applied on that, you get an array, which is really nice because often within the arrays. And the other way around is that if you got the, well, similar thing is that if you got the list of arguments, using off, you can get an array. And also you've got those 3 prototype methods and enters, keys, and values. So again, you can get the set of index and value from an array, or you can get the indexes only, or you can get the values. This one is kind of redundant because as I showed you before, you can just do it for on an array, you get the values. Also, you've got methods on the object. The set prototype of is pretty cool. Again, it allows you to set the hidden prototype for inheritance on specific objects. You've got the get prototype of already in this slide, by the way. Assign allows you to define mixins in JavaScript. Very cool feature. So basically, there's no mixin. Basically, you look through another object and you just copy the properties on another object. And that is to compare different values objects. Then you've got a few map methods. I'm not sure if you ever use those methods, but they're available. And now, last topic is proxies. That's one of my favorite topics. So proxies is about having metaprogramming in JavaScript. So you are able. So what happens is that if you have an object, you can apply a proxy on that object and then define interceptors on that object. And when I say interceptors, you basically are able to listen on specific internal operations applied on that object. So for example, you can listen on whenever a property on an object is set, or you try to retrieve a property on an object. And you can react when those operations happen. So an example is you've got this object literal with a num property. You can define a proxy like this, like you can see there. And the first argument is the target object, the one that you're going to listen on, and then you define the interceptors, which technically are called traps. So in this case, I'm setting the set traps. That means that every time I'm trying to set a property on an object, I will basically, this function will be called. And this function will have the target, which is the target object, property, which is the property that you're gonna you set the value on, and the value of the property. And you can redefine the values of the property. So if I I define this object, this property none, and it's equal to 1. If I ask for none here, I get 2. If now I define this none equal to, so it's internally you're going to do a set operation because I'm setting a property. Then when I try to retrieve the value of the object, I get 3 because what happens is that this internal operation that maps with this function, so it becomes 2 plus 1 equals 3, and I reset the target object. And the implication of this is that you can do stuff like mocking, logging, profiling. So, for example, think about you want to measure how many times you access to a variable in a specific time. That's sort of profiling. You can do this because you can have a get thread, so you can count the number of times you have access to a specific property. And yeah, by the way, those set, for example, applies to all the properties that you change on an object. That's another example. That's a way of, it's called defensive objects, a way of creating defensive objects. I took this code from Nicholas Zarga's blog, by the way. So this shows us how we can create those type of objects where we can ask for properties, and if we ask for properties that they don't exist, we get the reference error. So at the moment in JavaScript, if you've got an object literal and you ask for a property that doesn't exist on the object, we get undefined, which it's not really clear because you can define a variable as undefined, so it's not really clear if that property belongs to the object or not. So if you apply this kind of traps on an object, you can say, whenever I inquire for a property using get, like internally would be called get. If the property is on the object target, then I return the value of the property. Otherwise, I return the reference error. So in this case, I create this object with the property name. If I ask for last name, I'll get now a reference error because when I do this object of the last name, get an internal get will be called, which refers to this get method. And then the property doesn't belong to the object, so I return a reference error. That's really cool. And also further implication is that we can even define types we can create a way of defining types in JavaScript. So for example, think about setting variables like properties, initial values for properties on an object. So you can create traps that on inner gets, that every time you ask for a specific variable, you compare with the initial value. So if the initial value is the same as the one you're trying to set or get, that's okay. Otherwise, it's not okay. So it doesn't match the type that you initially defined. But I mean, there are like lots of things you can do with proxies. So kind of a small recap of what we went through today. So arrow functions, so the fat arrow function and how this is bound lexically. Scoping, so let and const, distracting, arrays and objects. Parameters, so rest parameters, spread operators, default values for parameters. Oops. Iteration and generators, so for off loops, iterators, generators, collections, so map, set, weak maps, modularity, classes, templates, API improvements, like a few new methods on arrays and objects, and proxies. There are also other features in ES6 that we haven't gone through today, so promises, which I would recommend to check it out if you're not familiar with. Better Unicode support, optimized tails calls, which basically means that if you got the recursive function in JavaScript at the moment, what happens is that the stack grows because so at the moment the stack grows. So with optimized tail calls, you just have a go-to reference, so the stack remains always the same. And then symbols, which is if you're familiar with other languages, is nothing really new. So the way you can use so as I said, ES6 will be released in June 2015, but you can still using it if you use transpilers. So if you use a transpiler that converts ES6 into ES5, you can still use all the syntax for most of the features. The most well-known compiler is Tracer from Google. I use Tracer, even though increases the size of the project a bit, plus inject in some cases Tracer runtime object global. There are other projects that allow you to do bits and pieces of the transpile bits and pieces of the specification, like def.js only for let and const. ES module transpiler from Square. There's also the Facebook transpiler. Recently they released a new one called 65, which is should be similar to Tracer but slightly better, like better performance. But you can't really do generators using the 65. And here I put a few links on compatible tables and the ES discussed board side, which is the side with lots of threads, advanced threads on how the proposals are going, bugs, and this is the link of this presentation on Speaker Deck. And that's all. I'm not sure if we've got time for questions. 5 minutes, okay. Any questions? Yep.
Can you set a trap on a specific property?
The question is if you can set a trap on a property in a proxies. No, you can't. The trap are like for all the properties. But you can determine the property because it's one of the arguments in the function. Yep. No, not much.
How this will affect future implementation in browsers and the JavaScript frameworks that support ES5 and later?
Okay, so a couple of things. AngularJS. I'm not a user, like I don't use AngularJS, but the version 2 is going to be built, the source code on ES6, for example. And some other frameworks are building on ES6. But the way that affects the browser, I mean, Chrome and Firefox, Chrome 38 just released yesterday. I saw before on Twitter they've got support for ES sets, maps, for of loops. Firefox has got really good support, probably better than Chrome. Well, IE probably IE15 will support all the features. But I mean, you can still use compilers. I mean, to me, it's a good thing to start using the syntax already now, because that means that we're not ending up like when Python 3 was released, that people like don't use Python 3 and like gets, you know. So if we start already using the syntax now, then it will be very easy to switch on the new version. Plus, we put pressure on Microsoft or to like implement all the features. Yep. Okay. Well, if you have other questions, or I'm just around. So yeah. Thanks.